Today we're going to be tackling a very difficult subject, but a very personal subject. I first of all want to make it clear that I'm not posing as a virologist or bacteriologist or an immunologist. I have no degrees in those areas, but I have a lot of experience in those areas. There's not a person in this audience who has not battled the cold or flu virus at some time, and many consistently have over the years. Why would a compassionate, loving Creator design a rattlesnake in microscopic dimensions by the billions, the most numerous living entities on earth are viruses. The second most numerous are bacteria. Why would a loving God design those when they're about to destroy each of us one way or another, and after we pass this life, they will resorb every cell in our body? This is a very difficult subject to address. But I want you to know there is an answer, a specific answer. We're leaning on the research of PhDs who are specialists in these fields. And within the last couple of years, some amazing research has come to light. This month's lecture, Creation Has Answers, the role of microbes. Those dirty little rattlesnakes. Do you know that you have more bacteria in your body than you have human cells in your body? You have more viruses than you have bacteria. We each have, and that's relying on the technical literature. But these microbes, this is a schematic of a bacterium. A bacterium is self-replicating. A virus is not self-replicating. Bacterium is self-replicating, and it's extremely complicated. Here is the capsule. I'll just point without the pointer. Here is the capsule. We see the nucleotide, the nucleotides here, the nucleid, the ribosomes, the plasmids, the cytoplasm. I'll not go into detail on those, but of very special interest is the little tail on this creature called a flagellum, a bacterial flagellum. Now, that propels the bacterium through the medium. Were it not for E. coli bacteria and other bacteria in the gut of our intestines, we could not digest the pizza that we're going to have for lunch, if you're going to have pizza for lunch, or the hamburger, or whatever. So it is absolutely necessary. We're going to learn in a moment that only 10 to 15% of microbes, including viruses and bacteria, are harmful. Only 10 to 15%. The rest are beneficial. So how does all of this balance out? Well, let's begin by showing that their function would be absolutely impossible, and if they did not function in the production of vitamin K in your body and the enhancement of vitamin E and vitamin A in your body, if they did not function and if they did not break down the material we eat, in the course of a matter of months, you would be dead. They are absolutely necessary. And for the vast majority of these bacteria, which are the central criteria, these bacteria, this little whip-like structure, this flagellum, is absolutely necessary to propel them through the medium. So let's take a look at the flagellum. It is absolutely awesome. This is a schematic by our special illustrator, Steve Miller, from the technical literature. That little propeller is able to propel the bacterium through the medium Because it has a motor. That motor has a ring, a rotor, an inner membrane. It has an outer membrane. It has a rod, the drive shaft, the stator, the studs and C-rings. It has the bushings. It has a hook or universal joint. It has all of the components of the starter in your car that enabled you to get here today. It is absolutely awesome. Let me show you how awesome it is. The technical literature illustrates that this little motor, by the way, it is not run on electrons, it's run on protons. That's much more sophisticated than the common medium of electrons, engineer. It is absolutely awesome. It can rev itself to 50,000 RPM. 50,000 RPM. That is faster than a jet engine. And amazingly, it can reverse that direction in a quarter of a revolution. It's astounding. There is no way that could have evolved. By the way, bacteria are found in all of the layers throughout the entire geologic column, down to the bottom Precambrian. Bacteria are found. It is awesome. And by the way, even in the Precambrian, some of the bacteria has been taken to the laboratory. They assumed it was fossilized. It appeared to be. But Dr. A.E. Wilder-Smith came here to the museum when we were embryonic. We were just that little double-wide trailer that Dr. Judkins just talked about. Dr. A.E. Wilder-Smith, a leading scholar, came and he said, they've just discovered that they have been able to revive some of these bacteria from the Precambrian that is assigned an age, I do emphasize assigned an age evolutionarily, 600 million years. So he said the obvious conclusion is it's not 600 million years old. That Precambrian is relatively recent, only a few thousand years old. And the geologic column supports that. Wow, that wrecks a lot of evolutionary theory.